Good morning, dears, and welcome to our physics class. Then we can directly go to our classes. In the last class, we have discussed or we have studied about electricity or what constitutes electricity, right? It is the rate of flow of charges, Okay, so hope you all done the works that I given in the previous class. Okay, so now we can get into another important terms, that is electric potential. Okay, so what is electric potential, that we have to know or we have to study. Electric potential and potential difference. Potential difference. Okay, so what does it means, or what is the difference between electric potential and potential difference? That all things we have to study. Okay, so now we know what is electric current. It is the flow of charge per unit time, right? So now the question is that what makes or what causes the charge flow through a conductor? What causes the charge flow? Or there should be something, there should be something that causes or that make the flow of charges, right? So what is the reason or what is the cause of this flow of charges? That thing we have to study. Okay, so what makes the electric charge to flow? Let us consider the analogy of flow of water. Okay, so charges do not flow in a copper wire by themselves, right? We know our bulbs will not glow by its own, right? So there should be something that makes the bulb should be glow, right? So what make it glow? Or the charges do not flow in a copper wire by themselves. That we all know, charges will not flow by themselves. Just as the water in a perfectly horizontal tube does not flow. So when we take water in a perfectly horizontal tube, that water will not flow. But if we tilt the horizontal tube somewhere like this or like this, what happens? The flow of water will take place, right? Okay. So if the end of the tube connected to a tank of water kept at a higher level such that there is a pressure difference between the two ends of the tube, water flows out of the other end of the tube. Okay, so what it says, you just read again. That is, it is an analogy of water. We have to find how the charge flow happens, right? So we just take an example of water flow. Okay, so water in a perfectly horizontal tube does not flow. If one end of that tube is connected to a tank of water kept at a higher level, okay, and such that there is a pressure difference between the two ends of the tube, right? So there should be a pressure difference between the two ends. That is, one end is at a level of higher level and one end is lower level, right? So there should be a pressure difference. Okay, so that pressure difference makes the water to flow through that tube, right? So water flows out of the other end of the tube. And for flow of charge in a conducting metallic wire, the gravity of course has no role to play. So gravity, that means gravitational force, does not have any role in the flow of charges, right? So what causes the flow of charge? That is, there should be the flow of charge in a conducting metallic wire. The gravity of course has no role to play. The electrons move only if there is a difference of electric pressure. Now we know if there is a pressure difference between the end of one end of the pipe and the other end of the pipe, then what happens? The water will flow from the tank to the lower end, right? Okay, so there is a pressure difference. That pressure difference create the flow of water. Like that, to the flow of charges. The flow of charges is due to a electric potential difference. That is, electric potential difference means, like that pressure difference we have electric pressure. Okay, so this difference of electric pressure is called potential difference. Potential difference along a conductor make the flow of charges. Okay, so a conductor have, or the metallic wire, a copper wire have two ends, right? So there should be a potential difference between the two ends. Then only the flow of charge from one end to another end takes place. Okay. So the difference of potential may be produced by the battery constituting one or more electric cells. So that potential difference can be given by batteries or cells, like that things. Okay. And the chemical action within a cell generate a potential difference across the terminal of the cell. Okay. So we know battery is having one or more cells. Okay. So inside that battery, what happens? The mechanical energy is converted into electric energy, right? That means a cell or battery gives us electric energy, right? Okay, so that makes a potential difference in that conductors or metallic wires. So what happens? Due to the working of this battery, there should be a potential difference, and then what happens? The flow of charges happen. That means electricity flow through the circuit. Okay. The chemical action within the cell generate the potential difference across the terminal of the cell even when no current is drawn from it. When the cell is connected to a conducting circuit element, the potential difference sets the charges in motion of the conductor and produces an electric current. Okay. അതായത് സെല്ലിൻ്റെ ഉള്ളിൽ റിയാക്ഷൻസ് നടന്നു കഴിഞ്ഞാൽ പോസിറ്റീവ് ടെർമിനലും നെഗറ്റീവ് ടെർമിനലും തമ്മിലൊരു പൊട്ടൻഷ്യൽ ഡിഫറൻസ് ക്രിയേറ്റ് ചെയ്യപ്പെടും, റൈറ്റ്? ഓക്കെ, സോ ഇഫ് ദർ ഈസ് നോ wires or the circuits connected to that terminals, that means the battery or the cell, then there should be no flow of charges. That potential difference is maintained in that cell only. അതായത് ആ സെല്ലിലുള്ള പൊട്ടൻഷ്യൽ ഡിഫറൻസ് അവിടെ മെയിൻറ്റെയിൻ ചെയ്യപ്പെടും, റൈറ്റ്? ബട്ട് വെൻ വി കണക്ട് or connect a metallic wire to one end of the cell and the other end of the metallic wire is connected to other terminal of the cell, what happens? That potential difference, that is the potential difference created inside that cell, that constitute an electric current through that circuit, right? Okay, so that is given in your textbook. So when the cell is connected to a conducting circuit element, the potential difference sets the charge in motion in the conductor and produces an electric current. Okay, so in order to maintain the current in a given electric circuit, the cell has to expand its chemical energy stored in it. Okay, so the cell, what does the cell do? The chemical energy is converted into electrical energy, right? So cell, what the cell do? The chemical energy, that is inside this cell there is something happened, right? So some chemical reactions have happened inside this cell, so that makes a chemical energy, and the chemical energy is converted into electrical energy. Okay, electrical energy. So this conversion is happen in cells and batteries also. Okay, so chemical energy, that is the energy inside this cell, that is converted into electrical energy, that is given to the metallic wires or the circuits, right? Okay, so that constitute electric current. And we define electric potential. So now we know there should be an electric potential that electric potential will cause the flow of charges, right? Okay, so how we can define electric potential? That is electric potential or electric potential difference between 2 points in an electric circuit carrying some current as the work done to move unit charge from a point to the other. So now we know there is electric potential and potential difference as well. Okay, so what is electric potential? Electric potential is something, or electric potential is the work done to bring a charge from infinity to a point. So here we have a point A and we have to get a charge from infinity to this point, right? So this somewhere infinity we have to get a charge from here to this point A. So the work done to bringing a charge from infinity to a point is known as electric potential. Okay, so if there is another point B, the electric potential to bring a charge from infinity to this point B, that is here we have infinity and this work is known as electric potential at B, right? That is electric potential at B. Here the work done to bringing a charge from infinity to A is the electric potential at A. Okay, so now we have 2 points A and B. So what is the potential difference between these 2 charges? So this is the potential difference between the charges. That means here we have potential, electric potential VA. Electric potential generally represented by the letter V. Okay, so here we have electric potential at A is represented by VA and here we have electric potential at B is VB. So what is the potential difference? It is the difference between these 2. That means VA minus VB or VB minus VA. Okay, these 2 are equal. That means this is the potential difference. This is the potential difference, that is VA minus VB. Okay, and the work done to bringing a charge from infinity to that point A is known as electric potential. Okay, electric potential. Okay, so hope you understood what is the difference between electric potential and potential difference, right? Potential difference is the difference between the electric potential of these 2 points. That means the work done to bring a charge from A to B. That is the potential difference between A and B. Okay, but the electric potential at A means to bring the work done to bring a charge from infinity to that point A. Okay, so now you just read the definition of potential difference. We define electric potential or electric potential difference between 2 points, that is potential difference between 2 points A and B is between 2 points in an electric circuit carrying some current as the work done to move a unit charge from one point to another. So the work done to bring a unit charge from A to B, right? That is the potential difference between A and B. The work done to move a unit charge from A to B. That is the potential difference between A and B. Okay. What is the potential? Electric potential? Electric potential is the work done to bring a unit charge from infinity to that point. Okay. So you should differentiate between these potential difference and electric potential. Okay. And then you should underline this thing. That is what is the definition of potential difference. That is, we define the electric potential difference between 2 points in a circuit, electric circuit carrying some current, as the work done to move a unit charge from one point to another. That you should underline. Okay, so potential difference V between 2 points is the work done to bringing a charge from one point to the another point, right? So the work done bringing a charge, unit charge from A to B. Okay, so we can represent V is equal to W by Q. Okay, so this is the potential difference. Okay, so if we write electric potential as V, what happens? This is also VA is also what? W by Q. That means this W, what is this W? To bring a unit charge from infinity to that point, right? But here to bring a unit charge from A to B, that is the potential difference between A and B, right? This is the potential difference between A and B. Anyway, what is potential difference? It is work divided by charge. Okay. So the SI unit of electric potential difference is volt. Okay. So electric potential SI unit of electric potential difference is volt, and it is represented by the letter V. Okay, and it is named after Alessandro Volta. You may be familiar with Alessandro Volta, right? Okay, so an Italian physicist who found the electric potential difference, and after that the SI unit is come to know from his name. Okay, so the SI unit is volt. So 1 volt is, we can define 1 volt, and in the previous class we defined what? 1 ampere. That means I is equal to Q by T. We know I is equal to Q by T, right? So I has a, that means electric current has a unit of ampere, and Q has a unit of coulomb, T has a unit of second. Okay, so from here we define 1 ampere is equal to 1 coulomb per 1 second, right? This we have already done in the previous class. So from here we can define 1 volt. So 1 volt is equal to what? We can define work done is expressed in the unit of joule, right? In physics we represent work done by the unit joule. The SI unit of work is joule. Okay. So the SI unit of work is joule. It is represented by the letter J. Okay. So we can define 1 volt is equal to 1 joule per 1 coulomb. Okay. So how we can define this 1 volt? 1 volt is the electric potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move a charge 1 coulomb from one point to another point. Okay, so what is 1 volt? 1 volt is the electric potential. This is electric potential difference to bring 1 coulomb of charge from one point to another point, right? So the work done to bring 1 coulomb of charge from one point to another point, that is 1 joule of work is done to bring 1 coulomb of charge from one point to another. Okay, so that also you should underline. What is 1 volt? This is the potential difference between 2 points in a circuit carrying it is the potential difference between 2 points in a current carrying conductor when 1 joule of work is done to move charge of 1 coulomb from one point to another. Okay, so hope you clear what is 1 volt, 1 joule per 1 coulomb. Okay, that means 1 joule of work done to move a charge of 1 coulomb from one point to another point. Okay, so that is 1 volt, and 1 volt we can write 1 joule per coulomb. Okay, so volt potential difference have another unit. From here we can write 1 volt is equal to 1 joule per coulomb. Okay, so volt has, or potential difference has another unit, joule per coulomb. Okay, so potential difference is measured by means of instrument called voltmeter. Okay, so voltmeter is another instrument that measures the potential difference. We have a meter to measure the electric current, right? Like that we have voltmeter to measure the electric potential difference in a circuit. Okay, so the instrument that used to measure electric potential difference is known as voltmeter. Okay, this voltmeter. Okay, this is also found in some circuits. Okay, and the voltmeter is always connected in parallel across the points between which the potential difference is to be measured. So it is connected. How the potential difference is measured? It is measured using voltmeter, right? How the electric current is measured? It is measured using an ammeter, and at that time we said that ammeter is connected in series to that cell and the bulb and that keys also, right? Okay, and in the case that case also I said that there is another way to connect these instruments, that is series method, and also there is parallel method, right? Okay, so the voltmeter is connected in parallel across the points between which the potential difference is to be measured. Okay, so voltmeter is connected in parallel. So the parallel connection and series connection we have to discuss in the coming classes. Okay, at that time you will be more clear how this voltmeter is connected in a circuit. Okay, so at that time we can discuss it in detail, that is series connection and parallel connection. Now you just understand what voltmeter is connected parallel to the circuit, that is always connected parallel across the points between which the potential difference is to be measured. Potential difference measure ചെയ്യേണ്ടത് എവിടെയാണോ അതിന് പാരലൽ ആയിട്ടായിരിക്കും വോൾട്ട്മീറ്റർ കണക്ട് ചെയ്തിട്ടുണ്ടാവുക. ഓക്കെ, and now we studied how the current flows through a circuit and what causes the flow of charges, right? And now we know what is the difference between electric potential and also potential difference. Okay, and here we have the equation for potential difference, that is work done per unit charge, right? Okay, so an example is given to you, that is a problem. Look into that problem. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12 volt? That is, what is the question? How much work is done? So we have to calculate the work done. We have to calculate the work done in moving a charge of 2 coulomb. That is, charge is given, Q is given as 2 coulomb, and 2 coulomb across 2 points having potential difference 12 volt. So potential difference is also given as 12 volt. So from these data we have to find work done. Okay, so how we can find? We know what is potential difference. Potential difference between 2 points, that is work done per charge, that is work done divided by charge. So from here we have W is equal to VQ. That means W is equal to V is given as 12 and Q is given as 2. So what will be the answer? 24. Unit of work is joule. Okay. So the work done is obtained as 24 joule. So 24 joule of work to be done to move a charge of 2 coulomb between the potential difference of between across 2 points having potential difference 12 volt. Okay. So that is the question. And here you have some more questions to be done. That is questions. Name the device that helps to maintain the potential difference across a conductor. So these all questions you have to do as homework. Okay. So you should do the homeworks properly. Okay. So you just do 1, 2, 3 questions. That is second question, what is mean by saying the potential difference between 2 points is 1 volt, and how much energy is given to each coulomb of charge passing through a 6 volt battery. So all these questions you have to done as homework. Okay. And you have to send these homeworks in the coming day, that is in the next day. Okay. In the next day itself you have to complete this homework. Okay. So that is today's class, and we can wind up today, and we have to study the symbols, and one more thing, the coming portions are so having more importance, that you have to study more detail about that coming sections, right? Okay. So you should, what you have to do, you should read and you should study the portions that we have already completed, right? അപ്പോൾ ഇതുവരെ എടുത്ത കാര്യങ്ങൾ എല്ലാവരും നന്നായിട്ട് പഠിക്കണം, എന്നാലേ നമുക്ക് കമ്മിങ് പോർഷൻസ് ക്ലിയർ ആയിട്ട് മനസ്സിലാവുള്ളൂ. ഓക്കെ. സോ we can meet in the next class. Till then, take care and should do properly do the homeworks. Okay. If you have any doubts, you can ask me. Okay. So we can meet in the next class, children. Thank you. Okay. So now we know what is electric current and how this electric current flows through a circuit, and what is electric circuit, that all things we know. And now we have to know, or we have to note that some symbols are used while making the diagram of, or while doing the problems in this chapter, or we have to construct electric circuits, right? So there we use symbols to represent the some instruments and battery, bulb, switch, like that things, right? Okay. So in the first class, the previous class we studied about electric circuit, and at that time we familiarized with some of the symbols used in that electric circuit. Okay. So circuit diagram constitute more symbols, right? Okay. So that symbols we have to study now. So we know that an electric circuit comprises a cell, a battery, a cell or battery, a plug key, and electric components and connecting wires. Okay. That all things we have already seen in the diagram, that is figure 12.1. Okay. And what is next? It is often convenient to draw a schematic diagram in which different components of the circuits are represented by the symbols conveniently used. Okay. And conventional symbols used to represent some of the most commonly used electrical components are given in your textbook. Okay. So we cannot draw the actual pictures of all these bulb, battery, switches, like that things. Okay. So it is convenient to use symbols. Okay. So what are the common symbols used in circuit diagrams that we are going to study, or we are going to see? The components is given, and also the symbols are also given in the right side. Okay. So what is an electric cell, that we have already know how we can represent an electric cell. Electric cell should have a positive terminal and a negative terminal, right? So this is positive terminal and this is negative terminal. So this is a cell. Okay, so this is a cell. And how we can represent a battery? Battery is a collection of cells, right? Two or more cells together constitute battery. So how we can represent a battery? Battery have one or more cells. Okay, so this is a one cell and this is another cell and this is another cell, like that. Okay, so this is a battery. Okay, this is a battery. This is also having positive and negative terminals. Okay, and plug or switch. Plug, key or switch, that we have already seen in the figure 12.1. that is, we can represent key like this and also we can represent key like this. Okay, these two representations are commonly used. That is, now the key is open, right? The key is open. That means the circuit should be an open circuit, right? That is, in the case of switches, that is off position, right? Key open means switch off, right? Okay, so when the switch are on, that means closed circuit means the keys are closed. We can represent like this. Okay, and if we represent this thing, what? This will be like this. That means these two together. This touches this wire. Okay, so these portions are metallic wires, right? These all portions are metallic wires, that is the conductors. Okay, through this electric current passes. Okay, so these are metallic wires which conduct electricity. Okay, so this is plug, that is on position, this is off position, right? Okay, that is open key and closed key, right? And what is next? What is next? A wire joint. A wire joint, how we can represent a wire joint? That is, this is the conducting wire and another wire from here comes to here and join together, right? So this is a connecting wire. Okay, and the wires crossing without joining. How we can draw wires without connecting? The wires are joined but they do not cross each other. That means here we have a conducting wire and another wire coming from here that will not touches this wire. How we can represent? That means this is how we can represent. That is, the wires crossing without joining. These two wires are not joined in this position, right? Okay, so here there is no joining between these two wires. Okay, that is, this is independent and this is also independent. These are not dependent each other. Okay, and electric bulb, how we can represent electric bulb? That we have already know. Here we have an electric bulb. Okay, this is bulb. And next, a resistor or a resistance. So resistors and how resistors work and all that things we have to study in the coming classes. Okay, so you just know how we can represent a resistor in a circuit diagram. That is resistors. This is a resistor. Okay, so resistors resist the electricity to pass through the circuit. Okay, so resistors make a resistance to the flow of current. Okay, so we use resistors to control the flow of electric current. Okay, so this how we can represent resistor? We can represent resistor like this. And there is also variable resistors, or we can say rheostat. Rheostat is also what is variable resistance. Variable resistance means sometimes variable resistors we can represent like this, or also we can represent the representation, another representation is like this. Okay, these two are what representation of variable resistance or rheostat. Variable resistors means the resistors itself can change the resistance. Okay, so in some circuits we cannot change the resistance of a resistor. That is, here we have a fixed resistance to this resistor. Okay, so it should be like that 5 ohm, like that. Okay, ohm and resistance have a unit of ohm. That all things we will discuss in the coming classes. Okay, so it have a fixed resistance, but rheostat or variable resistance can change the resistance by its own. Okay, so that is what we mean by variable resistance. Okay, and then ammeter, we have already know what is ammeter. Ammeter is the device or the instrument used to measure electric current, right? That we represent like this. And voltmeter also, that measure the potential difference between two ends, right? Okay, so that we represent like this. This is having also positive and negative. These terminals should be, this terminal should be connected to positive end, this should be connected to negative end, and here also this should be connected to positive end and this should be connected to negative end. Okay, so these are the some symbols that normally we used in the circuit diagrams. To draw the circuit diagrams, we have to understand these symbols and what these symbols gives us, or what are the components that represented by all these symbols. Okay, so these are the symbols normally we used in circuit diagrams. Okay, so using all these things we can study more about circuit diagrams in the coming classes. Okay, so now we are going to wind up today's class. And എന്തൊക്കെ നമ്മൾ പഠിച്ചത്? പൊട്ടൻഷ്യൽ ഡിഫറൻസ് എന്താ, പൊട്ടൻഷ്യൽസ് എന്താ, ഇലക്ട്രിക് പൊട്ടൻഷ്യൽ എന്താ, പൊട്ടൻഷ്യൽ ഡിഫറൻസ് എന്താ, ആൻഡ് വാട്ട് ഈസ് ദ ഡിഫറൻസ് ബിറ്റ്വീൻ ഇലക്ട്രിക് പൊട്ടൻഷ്യൽ ആൻഡ് പൊട്ടൻഷ്യൽ ഡിഫറൻസ്, ആൻഡ് ഹൗ വി ക്യാൻ മെഷർ പൊട്ടൻഷ്യൽ ഡിഫറൻസ്, ആൻഡ് then what is the unit of potential difference, and how we can define 1 joule, and how we can find the work done to bring a charge from one point to another point. That is, we have an equation V is equal to W by Q, right? Okay, so using that you should do, or you have to do the questions given in the page number 202. Okay, so that all questions you should do as homework, and you should submit the homeworks in the coming day, that is in the next day. When you hear these classes, when you get the classes and the coming day, the next day you should submit the homework. Okay, it is compulsory, you should submit the homework. Okay, so if you have any doubts you can ask me. Okay, so we can meet in the next class. Okay children, thank you.